let's look at these exponential functions and let's first review. So with exponential growth, the b value, the rate is greater than 1. When the b value is between 0 and 1, we consider it exponential decay. What does this look like? So exponential growth in which the a value is positive, looks like this. Oh, my pen's running out. Let me grab. All right, so when the a value is positive for exponential growth, it looks like this. What happens with exponential growth when the a value is negative? When it's negative, it's been reflected across the x-axis, and it looks like this. So this would be an example of exponential growth. Here the a value, giving an example, may be a equals 1, and here maybe it's a equals negative 1.5, just giving some random examples. Again, this is your y-intercept. Your a is your y-intercept. So this is exponential growth, and notice it's also concave up. This is exponential growth, and it's concave down, with the a value being negative. Now let's look at exponential decay. Often we relate it to things like the value of a car over time. It's looking like this. So this is exponential decay when our a value is positive. An example, maybe a equals 4 as an example. Now if we reflect this exponential decay graph over the x-axis, it looks like this. And this may be where a equals negative 2. So still exponential decay, but it's reflected over the x-axis with an a value that is negative. Now let's look at the next problem. It says we want an example that is decaying. So we want the b value to be between 0 and 1, and we want it concave up. So what does that mean? That means our a value, because this is concave up with decay, our a value must be positive. And our b value, when we simplify things, has to be between 0 and 1. Let's look. So when we look at our options here, let me cover up what we have down below so we can focus on number 9. First, I need to take this 2 and distribute it before I even look at things. So this is going to be 7 and 1 over 9 raised to the x. This is not changed at all, so 0.2 raised to the x. This is not changed at all, 1/5, 4 raised to the x. Here, I do need to apply this. Remember, 1/2 is like a square root. So when I take the square root of 9, I get 3 raised to the x. All right, so let's first start with the easiest thing, which is decay. Here we have a b value that is greater than 1. This is an example of exponential growth. Again, the b value is greater than 1. This is exponential growth. These would be examples of exponential decay. Why? Because this b value is between 0 and 1. Now we want concave up, and we drew that picture. And when we drew that picture, concave up again has an a value that is positive. So when I look at my choices, only one of these has an a value that is positive with exponential decay. Correct answer is A.